Okay guys, I'm back with solving simple trig equations, and this is part B, so you need to have watched part A, and I'm just going to look at a few more. This is a bit of a shorter one, and I'm going to go straight into this. Question 6, solve sine x is equal to minus root 3 over 2, and this time it's changed the range, and this is why this question is being posed between minus 180 to 540. So the wave is going on, so this sine wave is going on to 540, which is about there, I think, 540, another 180 degrees, and also going back to minus 180. So all of the values, you know, within here. Okay, minus root 3 over 2. Now again, if you inverse, ignore the minus, inverse root 3 over 2, it will give you 60 degrees. It's one of those exact values. Okay, so I'm just going to put x is equal, they've used x instead of theta here now, but x is 60 degrees. I'm just going to put that into brackets here. Okay, so they're talking about this angle here, but actually they're talking about the negative of this angle. Okay, so we don't want the angle in this quadrant or in this quadrant where sine is positive. We want it where sine is negative. So actually it's talking about this angle here, 60 degrees into this region, which is 240, adding 60 on, and taking 60 off, 360 gives us 300 degrees, okay? So we don't actually want the actual original acute angle of 60 degrees. So we know we've got 240 degrees, and we know we've got an answer of 300 degrees, okay? So we're starting from 0, we've gone 240, 300, and if we carry on to 540, well, 360 add another 180 takes us to here, 540. So round once and another half, and we know that in these two regions here, once we come around again, we don't have any values in here because we don't want the 60 and the 120 because they're positive. So there's no more higher than that, okay? But we also want to look at, we're not stopping at 0, we're going back here. We're going back this direction as well. And actually, this 270 can also be minus 90, and this can be minus 180 turning back. And if we turn back, again, remember we're sticking with this angle, it is 60 degrees. If we turn back 60 degrees, okay, like we did here for 300 from 360, but if we do it from 0, we're at minus 60, and if we go 60 into this one, there's minus 180, back is also minus 120. Okay, so turning from 0 to minus 180, we're turning 60 degrees into there and 60 degrees into there. It would be minus 60 and minus 120. So I'm going to go minus 120 minus 60. So those are the four, I hope that fits on. Those are the four values. X is equal to minus 120, minus 60, 240 and 300 for this within that region. If it had just said between 0 and 360, like it does in most cases, that's your window, okay? But it expands that window, and this bit creates two more values that fall into range, okay? That's that one done. If we look at another one, okay, this is an important one, 9, and it says tan squared theta is equal to 9. So this is an important one, and it's important because you're going to come across sine squared theta or cos squared theta or tan squared theta in a lot of equations, and you need to know how to deal with them. I'm going to show you now. Okay, so 0, 90, 180, 270 and 360. Obviously what we do, if it was x squared equals 9 with square root, to get x is 3, but this is A level, so we have to think of all the solutions. So when we square root both sides, of course, square root of 9 is plus or minus 3, isn't it? Okay, so that gives us two values. So tan theta is equal to 3, or tan theta is equal to minus 3. Okay, tan theta is equal to 3. You go to your calculator and we go inverse tan of 3 and press equals 71.5 degrees. So theta is equal to 71.5 degrees. Okay, let's put it in 71.5 on our cast wheel. That's what we've turned. Where else? In this region here, 71.5. So if I add 180 plus 71.5, I get 251.5 degrees. So those are the two 71.5s in those two quadrants. But minus 3, again, remember, it's the 3, so it still gives us the acute angle of 71.5, but the minus just tells us it's in these two quadrants. If I was in my brighter days, I'd be able to do 180 minus 71.5, no longer. Okay, so 180 minus 71.5, actually I could have done that one. Okay, so that is 108.5 degrees, 108.5, and I'm a bit embarrassed about that now. I'm not actually, I actually don't care. I couldn't give a monkey's. Okay, is 288.5 degrees. Okay, into that region. And those are the four values: 2 for 3 and 2 for minus 3. Tan equals minus 3. And that's how we deal with all of the squared. The squareds always give you actually four values always in each quadrant. Okay, because you're always going to get the two positive and the two negative values. I'll just do one more, I think, which is number 10. Okay, looks a little bit of a mouthful. It's one of the problem ones. Show that 4 sine squared x minus 3 cos squared x is equal to 2. Show that it can be written as 7 sine squared x is equal to 5. Okay, because it wants the answer, it wants you to work to this particular solution. It's asking you to change this into that. Okay, remember from our identities of sine squared x plus cos squared x is equal to 1, and the two that go with that is sine squared is 1 minus cos squared, and cos squared is 1 minus sine squared. So we're going to use the 1. We want the sine squared, so we want to keep that, so we just need to change that one, don't we? And this cos we're going to change to 1 minus sine squared x is equal to 2. Let's build everything else around it. So we're just going to swap this bit here, aren't we, for that, which we can. Okay, and then we'll just multiply this out. Minus 3 times 1 is minus 3, be careful. Minus 3 times that, minus times a minus is a plus. Sine squared x is equal to 2 for sine squared x. And 4 sine squared x plus another sine squared x there is 5 sine squared x minus 3. Add 3 to both sides, and that gives you the... What have I done? Oh, I forgot to, when I did that, I forgot to put my 3 there. Whoops. 4 sine squared x plus 3 is 7 sine squared x, and add 3 to both sides, and that gives me 5. Okay, I do apologise for that, it's late in the day, and I'm old. So once we get to here, of course, we're going sine squared x now is equal to 5/7, aren't we? We're dividing both sides by 7 to carry on and solve it. And then when we square root that, we know that sine x is equal to plus or minus the square root of 5/7. Okay, square rooting both sides. Get your plus or minus in like I did before. Okay, ignore that a minute. So just inverse sine the square root of 5/7 on your calculator. You're going to get a value of theta. Okay, and you're going to get the positive one, and then you want it in there for the other positive one, and then the two negative ones for sine are in here and in here. So whatever angle that gives you, the inverse sine of that, the square root of 5/7, okay, you want to turn there, 180 minus that, 180 plus that, and 360 minus that. Okay. And just a word about question 11. Okay, and get your 4 values from that. Just a word about question 11. In question 11, I'm not going to do that one. It does the same thing. It says show that this 2 sine squared x plus 5 blah 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 can be written like this: 3 sine square x is equal to 4. And do it the same way as we did the last one. And then it says explain why there's no solutions to this original problem. Well, this original problem can be written like that. And if we try and solve this one, of course, we get sine squared x is equal to 4/3 divided by 3. And we square root both sides, sine x. Well, the square root of 4/3, okay, is, the square root of that is 2 over root 3. Plus or minus square root of 2 over root 3, just square rooting top and bottom. And that is a value that is big. 2 divided by root 3 is a number that is bigger than 1. Okay, and you can see that sine only goes up to 1 and down to -1. So it's looking for a solution along here or along here, plus that or minus that. And there are no solutions because it misses the curve. The curve only goes up to 1 and down to -1. So there's no solutions to that. Okay, and you should be able to have a go at those. You know, I'm going to post another video up of the harder equations in exercise 10E for you. But those ones are quite simple. Have a go through those. There's a few that have missed out in between, sketching little graphs. It's good for your transformations. And have a good evening. Okay, thank you guys.